Hello everybody and welcome to my presentation on the need for holistic technical debt management across the value stream. I am Somaya Malakuti and together with my colleague Jens Huschkel from ABB Corporate Research Center Germany, we would like to share our experience and the open challenges that we have observed in applying technical debt management in practice. During past 3 years, we have been trying to apply the state-of-the-art technical debt management in practice. Our activity consists of multiple phases where we try to support one of our customers in their quality improvement activities. In the beginning, there was the assumption in the company that the modularity is the key source of many quality issues that they have, and we were asked to validate this assumption. We used different source code analysis tools to get insight on the quality of the software, and we realized that indeed modularity was an issue. In phase 2, we were requested to support the company in their modularity improvement at code level. There, the assumption was that due to the complexity of the software, it is not possible to have a good software architecture design of that at once, and therefore we need to take an iterative approach to improve the quality at the code level and eventually at the architecture level. In this phase, we also introduced LaTeX as the architecture assessment tools in the company. The learning that we had in this phase was that the current approach of quality improvement by only focusing on code didn't lead to the desired result. Of course, this was clear to us from the beginning, but we needed to also convey and convince our customer from this insight. Phase 3 in 2020 was about identification of strategies for systematic technical debt management. In this phase, we executed a survey in the organization to get more insight of the different stakeholders' perspective on technical debt that exists in their systems. We also tried to apply systematic technical debt management at the architecture level. However, we eventually had to stop it because we had to shift the focus on the competence development before applying the systematic technical debt management. The major learning that we had from this phase was that we have to move from reactive to proactive technical debt management. We will dig into this topic later during this presentation. Right now in 2021, we have the vision for competence development, process and infrastructure improvement. The major lesson that we learned was that reactive technical debt management may not succeed. In organizations with long-living systems, there are a variety of debts that are accumulated over years. These debts have causal effects on each other. Due to the complexity of systems, large number of debts, and their complex causal effects, finding the right starting point to repay debts is very challenging. Reactive attempts to repay some debt causes to frequently switching the focus, which eventually can create more debt due to unfinished activities. Here we try to illustrate some causal dependencies that we have observed in our case study. Architecture debt can eventually lead to more code debt. For example, if we don't have well modularized architecture, the code that we are implementing accordingly may not be very well modularized. The code debt can also lead to build and test debt. If we don't have a well modularized code, or build scripts and test scripts may not also be well modularized. The debt that we have in software code is not always related to the software problem. Sometimes this debt is coming from the debt that we have in the electrical component design. If we have infrastructure debt, for example, we are not using automated testing and building effectively, this will also lead to the build and test debt eventually. More importantly, we need to have people with the good level of competence, and if there is a competence debt, we automatically introduce debt into the system. By having such a complex dependencies among different categories of debt, the question is where and how to start. Our learning was that we have to move from reactive to proactive holistic debt management. But what does it mean? To have effective technical debt management, we should look at the entire value stream of software development. The value stream starts by defining the business strategy, followed by portfolio management. In the portfolio management, we have idea pool, portfolio planning, balancing, and performance, and eventually product roadmap. From the product roadmap and the customer requirements, we define the requirements of the system. We do architecture design, coding, testing, releasing. This process is supported by IT infrastructure and also a set of organizational processes. We have observed that any gap in the value stream leads to making suboptimal decisions in later stages and results in technical debt. For example, to have a proper architecture design, we need to have a clear understanding of requirements. But these requirements are also influenced by the product roadmap, which are also influenced by the portfolio and business strategy. And if we miss this information, eventually our architecture design and code will also be influenced. The extent of the work that we have for holistic debt management is rather large and naturally cannot be applied at once. Therefore, the major challenge that we observe is to define a roadmap that specifies the right combination and the right order of activities to effectively manage and repay various kinds of debt over time. For this, we face several challenges. The first challenge is about the taxonomy of debt categories and their relations. The second challenge is about systematic management of each debt category. Informally, one may consider technical debt as the delta between the current and the desired state in terms of the various quality attributes. Hence, to manage debt, we need to define the desired target state and its desired qualities, measure the delta, and define strategies to move from the current state to the target state. For each category of debt, it should be studied how these steps of systematic debt management can be applied in practice. Another category of challenge is related to the systematic management of the debt relations. Although the need for managing debt beyond code and architecture has been observed in the literature, there is a still noticeable need for systematic studies addressing different categories of debt and their relations. Where we cannot focus on one category of debt, we cannot fully repay multiple categories of debt at once. Hence, we need to define strategies to gradually repay some debt from some categories and accept some debt to be paid later. The next challenge is about integrated debt management processes. Technical debt management and more generally holistic debt management are ultimately processes which should be incorporated into the existing processes of companies. There are studies that define maturity level of technical debt management in companies. However, they don't provide specific guidelines on how to increase the maturity level and without studying the interplays of technical debt management process with other product development processes. The last category of challenge that we have observed is about insufficient objective measures to fill the communication gap between different stakeholders. It has been claimed that the notion of technical debt management can fill the communication gap between the technical teams and the management teams. However, our observation is that although extensive work has been performed on the code and architecture metrics, the existing metrics and measures may not suffice even for the communication among the technical team. Thank you for your attention, and I will be happy to answer your questions.
So, okay, so we'll come to the next paper, to the next presentation from this last session, technical session. So the next paper is presented by Somayet, and so the paper is about the need of a holistic approach about technical debt. So Somayet, please go ahead with your presentation.
Yeah, thank you. Hello, everybody, and welcome to my presentation of the need for holistic technical debt management across the value stream. So this is a paper that we wrote with the colleagues about the experiences that we had in introducing technical debt management in a company as our client. And we wanted to share the lesson learned and open challenges that we have observed there. To apply technical debt management in practice, especially in larger scale companies, you need to take a very iterative approach in multiple phases, because as part of the deal is to create this technical debt management culture in the company. So we started in 2018, and where the company asked us to validate their hypothesis that the modularity is the key source of their problems in their software, and we validated this idea by using different source code analysis tools, and we showed it, yeah, the modularity is really a problem. And in the next phase, they ask us to improve the modularity at the code level. Of course, we thought that we should start from the architecture level, but we couldn't convince the architects in the company because they believe that actually the architecture is in a good shape, but the code has a lot of problems, and we tried to improve the quality of some pilot modules in the code. But we also could show that using this exercise that the current approach of modularity improvement by only focusing at the code is not good enough, and we have to switch to the architecture level improvement. We also introduced LaTeX as an architecture assessment tool to their build system, but we also learn in this producing a tool is not enough. We really have to put a lot of effort to also incorporate that tool into the working culture of the company. Last year, we tried to apply some systematic technical debt management in practice, but we eventually had to stop it because of multiple reasons that I will explain in next slide. And we learned that actually we have to move from reactive to more proactive technical debt management, which I will explain in the next slide. And this year, we try to support the company by competence development, software architecture competence development. We try to introduce more quality metrics into their build systems and also try to establish some university collaboration for doing further research on this topic. So what we learned is that reactive technical debt management may not succeed because in the companies with the long living systems, there are a variety of the debt that are accumulated over the years. So we try to show an example here that we have architecture debt that can cause some debt at the code level as well. So then build and test debts can be also caused or by the code level debt or can also cause some other debts. Some of the depths that we have in the software is because of the depth that is in the electrical components design, so that come from there. The infrastructure depth that we have in terms of the build system and the test systems that we have, they can also impact the other depths, the build and the test depths. And sometimes also the process depth, like if the lack of processes for the technical debt management can also impact the other kind of depths that we have in the system. And ultimately, actually, the people debt or competence debt is a reason that we accumulate debts over the time. So with such a complex dependency graph, basically the question is that where to start repaying the debt, because we cannot just focus from one point and hope for the best, because we have to look at the entire picture. What we have been doing, or we were asked to do, is that we started from code level and we did a little bit improvement here. Then we realized that the code level improvement is not enough. We have to switch to the architecture level. And then we started doing at the architecture level. Then we realized, no, we have to also first focus on the competence step and improve the competence of the architects and also improve the processes that we have. So this is what we call reactively moving alongside this graph from one node to another, hoping that we can do something there, but then we realize we cannot do everything there. We have to switch to another node in this graph. And this doesn't lead to the result that we want, and we only kind of lose time and effort in this process. And the question is that where and how to start. So that's the challenge that we observed, and we tried to find an answer to this question, but we didn't really find an answer yet. So what we think it should exist is to move to a more proactive, holistic debt management. So what does it mean? In order to do technical debt management, we need to look at the entire value stream of the product development. The value stream starts by the business strategy and then portfolio management, that we have a pool of ideas, we do portfolio planning, then we have product roadmap, and then it goes to the software development phases that we have requirements engineering, architecture, design, code, test, and release. We have an IT infrastructure that supports us alongside this value stream, and we have a set of organizational processes as well. So if we only focus on one phase, let's say code level or architecture level, we cannot reach the desired result that we want to have. We have to look at the entire value stream, because any gap in this value stream can lead to suboptimal decision in later stages, and it can result to the technical debt. So that's the key message here, that actually without looking at the entire value stream, we cannot get where we want to get. Another thing that we learned was that for the holistic technical debt management across the value stream, we also need to rethink or reassess the agile processes and implementation of agile practices in the company. Currently, usually it is like this, that we have different Scrum teams, and each of them are kind of focusing on a specific product, and they are working on they have the freedom of making their design decisions for those products that they have. What oftentimes is missing is the coordination and systematic coordination across these teams. Because for the inter-product dependencies, we need to have systematic coordinations across the different products. And if this systematic coordination is missing, so these inter-product architectural decisions will be also impacted, and this can result to the technical debt. But also we need to have more agile strategic portfolio management for the inter and intra-product dependencies. And this strategic portfolio management can derive course and futuristic architecture decisions. So if we only focus on the Scrum teams and we are happy that we have Scrum teams and they have their backlogs, and so it's not enough. We really need to have more systematic coordination and also more agile strategic portfolio management in order to have the depth management across the value stream. So that was another lesson that we have learned throughout this exercise. What we tried to define a conceptual model for the holistic depth management, and this is the model that we have now, which is inspired from the existing work. We have a depth item, could be technical depth. Technical depth could be depth in the electrical components, software components, mechanical components. And then we can have people depth, portfolio depth, process depth, infrastructure depth. And there are different kinds of depths in each category. For us, what is important is these causal dependencies between different kinds of depths that we miss in the literature. So we cannot just ignore these impacts that the different kind of depths have on each other, because without knowing these impacts and without planning for repaying those dependencies, we cannot have a good technical depth management for a specific software component as well. So we have identified a set of open challenges for holistic depth management. Actually, the main question that we had is that what is the demarcation of the technical depth management from other topics? Because if you only focus on the architecture or code level technical depth management, so this is the topic that has been studied in different areas with under different names. So why do we have the name technical depth management now? So that is for us was one of the questions, and we tried to find an answer to this question. The first topic that we identified was that although there are some taxonomy of technical depth, but still these taxonomies don't converge really. There are some inconsistencies across different taxonomies, but also these taxonomies don't cover the relations between different kind of depths. So that's something that is still open for the research community to really look at this perspective as well. Another topic that we identified was that, okay, yes, architecture and code level technical depth is receiving a lot of attention, but for other different other kind of depth, we don't see as much attention in the research community, and it leaves us open to know what are the best practices to repay, for example, the process depths, infrastructure depths, competence development in the companies, and so on. So those are the areas that haven't received as much attention, and we felt the need of really getting some guidelines from the research community of the best practices in those areas. Another area which is pretty much open for further exploration is the systematic management of the depth relations, because again, without looking at these relations, we cannot really repay the technical depth as much as we wish for. And here it becomes the multi-objective optimization approaches which are become very relevant, because we have to make a trade-off between different kind of depths,